On this page, we'll go a little bit further into standard deviation and just looking at examples and seeing what kind of conclusions can we come to as far as standard deviation and variability of a data set. The standard deviation is a measure of spread. The standard deviation is approximately the average distance of the data from the mean, so it's approximately equal to the average deviation of the mean. They're going to be close to each other. They'll kind of both give you about the same feel for the variation of a data set, but they won't give you the exact same value. They're a little bit different formulas. The mean plus or minus the standard deviation gives a range of typical values. Now we incorporate the standard deviation into our analysis of a distribution. More specifically, we'll use standard deviation to compare the variability of two distributions. So down here, here's an example of comparing two distributions using the mean and the standard deviation. So below, we don't have dot plots anymore, as we've seen in previous recent pages. We have histograms that show the backpack weight carried by two groups of school children. One is a group of 1st and 3rd graders. The other is a group of 5th and 7th graders. Nowadays, kids they just carry a computer around with them, right, or a tablet or something, but back in my day, they used to carry a bunch of textbooks, and the older you get, the more textbooks you have and the heavier they are. But in each histogram, we mark the mean and the standard deviation about the mean. So let's see, down here, the very first histogram is 1st and 3rd graders. So notice that all the values are 12 pounds or below. I think they're using pounds here. Did they say? I don't see that, but I'm imagining it's pounds, I guess. And then vertically, that's the number of students in that category, the number of pounds. But then you see with 5th and 7th graders down below here, there's a much more variability. And like we said, that depends on how you measure variability, but it looks like it's spread out much more. The backpacks go from anywhere from 2 pounds all the way over to 40 pounds, or somewhere in there, 39 pounds, I guess, depending. That's pretty heavy. I think that's way too heavy for a kid to be carrying, but anyway, that's neither here nor there. I guess that's the conclusion you're supposed to draw from this. Let's see. So, for easy visual comparison, where are we? We made the histogram bin widths the same. So even though the 1st and 3rd graders, there are no values over here in the higher poundage, is that a word? The higher values, pounds-wise, we just want to compare apples to apples here. So because the 5th and 7th graders have higher backpack weights, we're going to just have the same range of values in our histograms. This decision made the histogram of pack weights for the 5th and 7th graders a pancake. For this distribution, a larger bin width will give more accurate sense of shape. However, since our goal is to compare the two groups, I think they're saying, so down on the bottom one, the 5th and 7th graders, it's hard to kind of compare the heights of all these bars. They kind of just all look like they're really low. But really, if you were to just look at this different, I guess, with different x values here, they don't both go up to 40, only one of them goes up to 40, it would be much easier to compare. Yeah, so if you're looking at the 1st and 3rd graders histogram, you'd probably just look like within the circle that we just wrote. You wouldn't even include these data values over here. It'd be too much. But just because we're trying to compare variabilities, we're going to go up to the same x value. Our observations about shape, center, and spread. So for the top histogram, the 1st and 3rd graders, the distribution appears to be somewhat symmetrical with a slight skew to the right. So it's symmetrical about the middle, so we're imagining this is somewhere in there is probably the mean, or close to it. They said it's right here, this blue bar. But notice that the bars to the left of the middle are higher than the bars to the right, so it's skewed to the right, like they said. Center and spread, with StatCrunch, we determined that the mean is 5.8 pounds, and the standard deviation is 2.1 pounds. Okay. Typical range of values. A standard deviation either side of the mean gives a typical range of values. So you're taking the mean and you're adding the standard deviation to get the highest value of your typical range of values. Okay, that's what they're doing here. They got 5.8 is the mean plus 2.1 is the standard deviation. So the highest value is 7.9, and then the lowest is the mean minus the standard deviation. That would be your lowest value in the typical range of values. And what they get here, 5.8 minus 2.1 is 3.7. So typical 1st and 3rd graders carry between, so you've probably heard that in studies. Oh, typical, whatever they're talking about, in this case, 1st and 3rd graders, Typical first and third graders carry between... So you might have wondered, how do they know it's typical? I mean, of course, some are higher, some are lower than that range. But it's kind of even more complicated than you would imagine, right? The standard deviation thing. But let's compare to the other set, 5th and 7th graders. So I guess in this video you can no longer see the histogram, but I guess you could scroll up as you're looking at this page. The shape and deviations from the pattern, to describe that, we say that the distribution appears somewhat uniform with 2 students who appear to be outliers. So it kind of looks like a typical bell-shaped curve, but there were 2 outliers that had a lot of weight. They were way off to the right. Center and spread, with StatCrunch we determined that the mean is 14.2 pounds and the standard deviation is 7.2 pounds. So they calculate the typical range of values the same way, like we said before. It's the mean plus the standard deviation, and then the mean minus the standard deviation. Here they did the lowest value is 7.0, the highest value is 21.4. So that's quite a range there. From typical 5th or 7th grader has between 7 pounds and 21.4 pounds. That's quite a range, huh? Here's another view of the same data. The standard deviation hat plot marks a standard deviation above and below the mean, so the gray rectangle shows us the typical range of backpack weights that we calculated previously. So here, when we compare the standard deviation hat plots, we can see that there is much more variability in the typical backpack weights for older students. The gray box down here is much wider, or longer, yeah. So we can see that the typical weights for each group do not overlap much. Gray boxes barely overlap. Yeah, there's not much overlap here vertically. Yeah, let's see now. From this analysis, we see that the group of students in the 5th and 7th grades carry more weight on average in their backpacks. The mean weight for this group is 14.2 pounds compared to 5.8 pounds for the group of 1st and 3rd graders. There's also more variability in backpack weights in the 5th through 7th grade group. The standard deviation for this group is 7.2 pounds compared to 2.1 pounds for the younger students. If we use the standard deviation about the mean to identify typical backpack weights, typical older students in this sample are carrying between 7 and 21.4 pounds, compared to typical younger students who are carrying between 3.7 and 7.9 pounds. The minimal amount of overlap in these intervals supports the thesis that older children carry more weight in their school backpacks. One plausible explanation is that as children get older, they're assigned more homework, so they have to carry more in their backpacks. However, the larger amount of variability in the weights of the backpacks for the 5th and 7th graders suggests that some students are not taking books home. They may be completing homework at school or not doing the homework at all. True. But imagine, this was a ways back when students actually took textbooks home instead of just computers.